So good morning, everyone. So here, so we are talking about random arrays, right? So in random arrays, okay, I said about like different functions. So I said about there is a function called random integer. So this random integer function, it will try to generate a random single integer value, or it will create an array of values. And you can generate the random array of values by giving what here? Size, right? So this is what we have said. And after that, I said some of the examples of working with the random samples or integer values. I said how to create with the different shapes. Like I said about how to create 1D random samples or random integers and 2D random integers as well as 3D random integers. So after that, I said about, yes. So example of generating samples or integer values between the given range. So here, this low and high can be either one value or it can be more than one value. So if you are writing random integer, so it will generate a random samples from 1 to 5, 1 to 8, and 1 to 10. Means this returns 1D array. So this is also returns 1D array because until unless you don't define the shape size, always it will generate which array? 1D array. So it will generate one random integer value from 1 to 6, and it will generate one random integer value from 4 to 20, and it will generate one random integer value from 10 to 60, right? So this is what we have seen. And after that, I said about random dot choice. Now this generates a random sample from a given 1D array. And this is a syntax here. You are writing an array from array, 1D array, from 1D array. It will try to generate one random sample, right? So this is what we have seen, like how to see or how to choice. I mean, how to read one random value. It can be one or it can be more than one. So if you want to pick multiple values, then you are trying to use, what you are trying to use is size. So size can be either single dimensional array or it can be multi-dimension array, right? So here you can give the size 3 into 3 and size is given what here? 20. Means it will pick how many values? 20 values. But if you say replace is a false, the same value will not be picked again. But if a replace is 2, then the same value can be repeated number of times. So that is a keyword argument called replace. The value of replace can be either true or the value of replace can be what here? False, right? So that's it. So this is what we have seen in the last class. And then after that, you have some more functions. So that is random dot rand, R-A-N-D. So there is a function called this. This is nothing but creating an array with uniform distribution. Okay. So there is a function called so these are the two functions here. So there is a function called random dot RAND. So there is a function called random dot RAND, right? Random values it will generate. So this is also generate some random values. So just to see here. I'm just trying to import. So numpy dot random. So just see the documentation here. So what is the name of the function is rand. So what this function will do is, now you can see this is, so it is a function. So helper, that is, so random state and the random values in a given shape. So if you see the syntax of this is, now let me explain this in detail. But before that, just write about what is this exactly random is. Random values in a given shape. Random values it will generate in a given shape. Now if you see this syntax of this random, this is a syntax of random. If you see the syntax of random, you are trying to use RAND and you are trying to give some random arguments. You are giving random arguments. So what it is written, generally it will return ND array and it will also return which one? Shape. It will return the ND array and along with what here? Shape. So what will happen exactly is, now you are trying to write like this. A random it followed by D0, D1, D2. Okay. So this is nothing but random distribution. Okay. This is nothing but random distribution. It is having some parameters. What are the parameters it is having? D0, D1 up to what? Dn. It is an integer or it is what here? Optional. So the dimensions of the returned array must be non-negative. If no argument is given, a single Python float is returned. It is returned single float value. Now this is parameters, but what it returns? Generally, create an array. Actually, what it will do is, it will create an array. Array and what it will do? It will create an array of given shape. It will create an array with given shape. It will create an array with given shape and populate it with the random samples from uniform distribution over 0 to what here? 1. But where 0 is not included and 1 is not all, 0 is not included and even 1 is also not included. 0 is not included and even 1 is also not included. You have to understand this. Here 0 is not included and 1 is also not included. So it will generate a random sample over uniform distribution over 0 comma 1. 0 comma 1 means it will generate a value. It will generate one random sample by using which distribution? Uniform distribution between 0 and 1. Means 0 will not be included and 1 is also not included. Uniform distribution. Uniform distribution is represented on chart as what? Straight line. Straight line or not? Yes. But if it is normal distribution, it is what? Bell symbol, right? This is uniform distribution. This is what? Uniform distribution, that is 0 comma 1. I'll try to repeat this again when we go for matplotlib, where we'll try to represent this random samples on chart by using uniform distribution. We'll try to generate this random samples by using what do you call it as normal distribution, right? But now just try to understand, it will try to generate the random values by using which distribution? Uniform distribution between 0 and 1. But 0 is not included and 1 is also not included. Now you are giving a random and here you have D0, D1 and up to what? Dn. So this D0, D1, Dn, these are optional. And this returns what here? Dimensions of the array. It must be non-negative and always it returns. So D1, D0, D1 and up to Dn, it is an integer and it is optional. And what it is exactly? The dimensions of the returned array. The dimensions of the returned array must be non-negative. It is a dimensions of written array and it is non-negative. It is a dimensions of written array and it should be non-negative, right? Yes, see here. So I just open Jupyter notebook here. So what will happen here? Yes, I'm trying to write import. So from numpy dot, or I'll just write import numpy dot random. Import numpy dot random as what here? Or so import numpy dot random. Now this module you are referring with one alias name, and what is the alias name here? R, right? So after this, what I'm doing is I'm creating an array with a random sample using which distribution? Uniform distribution. Okay. Then what I'm doing, I'm writing R dot RAND. But are you giving any input? No, you are not giving any input. Input is not given means it will return how many values? It will return how many values? I just print a value of A. It is written how many values? One value. So what is this value? 0.54. I said it will generate the value between 0 and 1. It will generate the value between 0 and 1, but where 0 is not included and 1 is also not included. 0 is not included and 1 is also not included. If I am writing a B equal to R dot RAND, if I am writing 5, if I'm writing 5 or if I'm writing 3, so 3 is nothing but it will generate how many values? 3 values. It will generate how many values? 3 values are generated. You can see 0 0.38, 0 0.80 and 0 what? 36. Now these are what here? 3 float values, but here 0 and 1 is included? No. So 0 is not included and 1 is also not included. If I'm writing a C equal to R dot random, I want to generate some 5 values. If I'm trying to say print C, it will try to create an array with how many values? 5 values. See here, it is try to generate with how many values here? 5 values. 5 values are there. 1, 2, 3, 4, 5. Now if you want to create an array with 2 dimension, R dot RAND, I'm writing 3 comma 3. If I'm writing a 3 comma 3, it will create a 2D array with 3 rows and 3 columns. Here it is created a 2D array with how many values? 3 rows and 3 columns. If you want to create a 3D array, okay, I'm writing R dot RAND. If I'm writing 2 comma 2 matrices and 3 rows and 3 columns. Now this is which dimension? 3 dimension. This is which dimension? 3 dimension. You can see. So you are creating a 2 matrices and each matrix is having 3 rows and 3 columns. Now here parameters are there. What is this parameters represents? Dimensions. Okay, this is, if you don't give anything, it is 0 dimension. But if you give, it is 1 dimension, 2 dimension, like that. So create an array of given shape and populate it with a random sample from uniform distribution over 0 comma what is that? 1. And it will return always a value size which type? Float type. It will return always a value size which type? Float type, right? Uniform distribution. Uniform distribution. You can see, suppose if you take this array, now you can find the values like 0.95, 0.49 and 0.8. But 0 is not there and 1 is also not there. If you want to read values, you can use which loop? For loop, right? How many ways can you read the data from array? So there are different ways of reading the content of array or not? Yes. You can use for loop, you can use indexing, you can do what? Slicing, you can do all these approaches to read the content of this array. This is clearer. RAND. So RAND create an array of given shape and populate it with random samples using which distribution? Uniform distribution. Okay, uniform distribution. Suppose assume that you have an array. Okay, you have a suppose assume that uniform distribution means, for example, so there is a assume that a best example is the coin. Coin is having how many values here? Two values, right? So if you toss the coin, you'll get only one value, right? Either head or what? Tail, right? Suppose if you take dash, it is having six shapes. Okay, assume that six sides are there. Okay, if you dial this dash, you'll get how many values? Only one value. That is what? Uniform distribution. Getting or not, right? But we'll try to see this again once we move to matplotlib, where I'll try to represent this data on a graph by using which one? Matplotlib, using uniform distribution. So you can also generate, you can also generate, you can also generate it. You can also generate it by using another function. There is one more function is there. And what is the name of that function is uniform. There is one more function is there, and the name of that function is uniform. So what is the name of that function is uniform. So the next function is uniform function is there. Okay. So random dot uniform, random dot uniform. This is one more function. Random dot uniform. So this is also generate, okay, a random sample by using which distribution? Uniform distribution. This is also generate a random value. This is also generate random value by using which distribution? Uniform distribution. So you can see uniform, but here you are giving inputs. But there you are not giving any inputs. But here you are giving what? Inputs. But what is the default? There you are not giving any input. But what is the default? Low is 0.0. What is the default high is 1.0. Default low is 0. So there also you in RAND you are just writing RAND. What is the default low is 0.0. What is the default high is 1.0. But here uniform distribution you can able to generate yeah, random samples from given low and what? High. But there I cannot give low and what? High. But here I can give what? Low and high. That is where you find difference between uniform and what? RAND. So only the inputs. Here I can able to give the inputs, but there I cannot able to give what? Inputs. So draw the random samples, draw random samples or draw samples from uniform distribution. And samples are uniformly distributed over the half open in the travel low to Y. Low to what here? High. So includes low, but excludes which one? High. Includes low, but excludes which one? High. High value is not included, but whereas a low value is what here? Included. But in RAND, 0 is not included and 1 is also not included. Okay, it will generate between 0 and what? 1. But in this case, is it low is included or not? Yes. Low is included, but high is not included. Okay? Yes. Now, what is the syntax of this is you are writing like this: uniform, uniform, uniform. It followed by yes. The low is 0.0 and high is 1.0, and there is a size. Now here size defines how many samples you want to generate with dimensions. How many samples you want to generate with the dimension that is defined by using what? Size. Okay. Now draw samples. Okay, draw samples from uniform distribution. So no data type is given here because this will generate by default the value says which type float type. It will generate values by default as which type float type. So samples are uniformly distributed over half open interval, that is low to what here? High. So includes the low but excludes which one? High. Includes the low but exclude the high. In other words, you can see, yes. So a lot of things related with this. Okay. So these are parameters you have. And what is the parameters here? Low. So it is a float or array like of floats optional. This is optional. If you don't give it, what is the default value is 0. And there is high. This is a float or array like of floats. Array like of floats, which will define which boundary? Upper boundary of the output what? Interval, right? And all values are less than or equal to which one? High. If not, then it might generate what? Some error, or it may not generate the values. So these are two parameters. One is a low. So there is a parameter called low. So low is a parameter. It is a float or array like of floats. So which will define the interval or range, lower boundary of the output interval. It is optional. It is optional and all the values are generated. It is optional, but all the values are generated. It is optional and all the values are generated greater than or equal to low. The default value is what here? 0. See here, greater than or equal to low. Means 0 is included or not? Yes. And there is a parameter high. So this is an upper boundary. This is upper boundary and this will generate. So float or array like of floats, upper boundary of the output interval and all values are generated will be less than or equal to which one? High. Okay, so it uses again uniform. It uses what again? Uniform distribution. Let me tell you, see here. So now just try to see it. For example, see here. So I'm writing here A equal to R dot, R dot. So what is the name of the function is uniform, but I'm not giving any input. So is it any input is given? No, it will generate one uniform sample. It will generate one sample using uniform distribution. It will generate how many samples? One. It will generate how many samples? One from 0 to 1. 0 to 1, 0 0.0 to 1.0. Because are you given low and high? Are you given low and high here? No. You are not given low value and you are not given high value. So it will generate how many samples? One sample. Now if you run this code again, Is it the same value generating here? No. You can see the value generate between 0 to 1. See here. If you run this, it will generate the value between 0 to 1. See here, 0 to 1. The value generated is between 0 to 1, right? You can also give the range. So B equal to R dot uniform. B equal to R dot uniform. Okay. Now I'm giving a low. Low is what here? 1. Low is a 1 and high is what here? 5. So I want to generate a random samples. I want to generate a random sample using which distribution? Uniform distribution from 1 to 5. 1 to 5. If you run this, sorry. So what is that? Uniform. Sorry. So if you run this, you can see 4.34. 4.34. If you run this, what is the value it is given? 1.90. If you run this, what is the value it is given? 3.23. If I run this, what is the value it is given? 4.9. Right? But how many values it generate? One value. How many values? One value. Now suppose if you see dash is having how many sides? 6 sides are there. Okay, if I dial the dice, I'll get only one value. Okay, that is uniform value. What is the value it is get here? 1.56. And if you want to generate number of values, 1D uniform distributed values, then you are using uniform. I'm saying 1 comma. So 1 is a low and I'm trying to give 10 is what? High. So 1 is a low and 10 is a high. And here I'm giving what? Size. Size is given. Now size represents here. Size represents how many values you want to generate. That is also define dimension or shape of the array. That is also define the dimension or shape of the array. I want to generate how many values? 5 values. I'm trying to say print. Print what is that? C. Print C. And if you print C, you can see 3.29, 6.16, 7.6, and 2.15, 6.66. Now these are random samples which are generated by using which distribution? Uniform distribution, right? So size is given what here? 5. It means this is which array? 1D array. C dot n dimension. If I write C dot n dimension, what is the dimension of this array? 1. What is the dimension of this array? 1. If you want to create a 2D array, I'm saying R dot uniform. I'm saying 1 comma 10. I'm writing a size. Size equal to, I have to give the tuple. So here I'm writing 2 comma 2. 2 comma 2 means I'm giving a 2 rows and 2 columns. Now total how many samples it generates? 4 samples, right? Now this is 2D array. This is 2D array. And if you want to generate R dot uniform, I'm saying 1 comma 10. 1 comma 10, I just write a size. Okay, 2 comma 2 comma 2. This is which array? 3D array. 3D array with how many samples it generates? 8. It is nothing but 2 matrices and each matrix is having 2 rows and 2 columns. Okay, 2 rows and 2 columns. So you can see this is a matrix with 2 rows and 2 columns, and this is a matrix with again 2 rows and what? 2 columns. Now that is done again by using which function? Uniform. Understood, right? So uniform distribution, it is done by using two functions. One is RAND and one more is what? Uniform. So there is one more function also there. There is one more function. See, all this normal distribution, uniform distribution, all these are used when you are working with the data science. Best example, if we take off normal distribution, it is very much helpful to find out outliers. Outliers means which is not within the range. So to remove those values, that is very much helpful when you are working with data pre-processing. Data pre-processing, all these methods are very much helpful, right? Yes. Normal distribution, uniform. Suppose you have a heights of, assume that you have a heights of some 10% heights are there. Okay. 10% heights are there. So this 10% average height is, okay, fall like this. This is called as average means what here? Mean. Okay, right? So it might be either below average or it can be what? Above average. For example, there is a person whose height is some 9. Whose height is what here? 9. It means it is not fall. It is not fall either below or what? Below or what is that? Above. It is separate height. It is what? Separate height. This is called as which one? Outlier. Now this values has to be deleted. This values has to be deleted or this values has to be replaced by applying some mathematical equations. Now this kind of things, you can do it by using which one? Normal distribution. Normal distribution, right? Okay. So there is a lot of applications of this. What do you call it? You learn different types of distributions like normal distribution and uniform distribution, right? Yes. Now you can also generate, you can also generate, you can also generate the random samples from the population by using one more function is there. What is the name of the function is RANDN. There is a function called RANDN. So what is the name of the function is RANDN. This is the name of the function. And what this function is doing is it will try to generate a random samples. It is also generate the samples from which one? From which one? Normal distribution. It is not uniform distribution. It is from which distribution? Normal distribution. It is not from uniform distribution. It is from normal distribution. Normal distribution is represented on the, what do you call it as graph as what? Bell sign, right? So bell curve like that, right? So that is standard normal distribution, right? So now this method, okay. What is the name of this is RANDN, random dot RANDN. This is the name of the function. This is the name of the function. Okay. And what this function will do? Okay, this will generate, what it will generate? A random sample. It will generate a random sample, return a sample from standard normal distribution. Return a sample, return a sample or samples because you define dimensions, right? Size. If you give this size, it will generate number of samples. If you don't give the size, then it will generate only one sample. If you give the size, then it will generate number of samples. If the size is not given, it will generate how many samples? One sample, right? So using standard normal distribution, right? So this is, so it is having only parameters like this, dimensions, and this is nothing but size. Okay, this is nothing but what here? Size. So there is only one parameter, that is, yeah, parameters. So here parameters. Okay, so this normal distribution is also called which one? Gaussian distribution, and it will generate the mean. Distribution of mean 0 and variance is what here? 1. It will generate a value by using a mean with what here? 0 and variance is what here? 1. So it means it will try to return one value, a float value, run a single float value, a single float value randomly generated float value by using which distribution? Normal distribution from 0 as a mean and 1 as what here? Variance. 0 as a mean and 1 as what here? Variance. So parameters, it is having D0, D1, Dn. It is integer or optional. What it define? The dimension of the return array. And this must be non-negative. This must be non-negative, right? So D0, D1, Dn, it is integer and it is optional. What it define? The dimensions of returned array. The dimensions of returned array. So distribution of mean is 0. So it will generate a value. If positive integer like arguments are provided, rand array and n generates an array of shape. So filled with random float samples from normal distribution of mean is 0 and variance is what? 1. Mean is 0 and variance is what here? 1. So it will generate. What it will do? It will generate a random sample, okay, from, yes, what is the mean as a 0, but variance is what here? 1. Mean as a 0 and variance is what? 1. It will generate one random value, right? Just to see it. So again, you have to know how to calculate mean, how to calculate variance, how to find out the standard deviation. Based on that, it will try to generate one sample. But I just try to tell you how these values are generated. So A equal to, I'm writing R dot RANDN, RANDN, but I have not given any shape here. I have not given any shape. Okay, dimension is not given. How many values I want to generate? I have not given. Then it will generate how many values? One value. It will generate how many values? One value. So one value is generated here. This is one value it is generated. If you run this, okay, this is one sample. This is how many samples it generated? One sample. See here, this is one sample, right? So this is one value it is generated. If you want to generate multiple values, you are saying RENDN, just give the size here. What is the size is given here? 5. Means it generate an array. Which array it is? 1D array with how many values? 5 values. If I'm writing a C equal to R dot RENDN, if I'm writing 3 comma 3, it will generate a 2D array with how many values? Some 9 values. That is done by which one? Size. You can give a size. Yes, that depends on, yes. Yeah, you get a negative values also. Yes. Yeah, you get a negative values also. Yes. You get a negative values. Yes. So mean as a 0 and variance is what here? 1, right? So here you get a negative values. Now these negatives are outliers, right? Yes. So now you can just write here D equal to R dot RENDN. You can give 2 comma 2 comma 2. And if I print D, now it is create a 3D array with 2 matrices contain 2 rows and 2 columns. 2 rows and what is that? 2 columns, right? Yes. So this is how you are trying to generate, okay, random samples, okay, by using which distribution? Random samples by using which distribution? Normal distribution, uniform distribution, and one more is what? Normal distribution, right? Yes. It is just like a curve. Bell symbol or not? Yes. So the difference, so the middle value is a mean. Okay, so there might be samples at left mean and right, right? So that is what you learn generally in mathematics, right? So this is an example for this. Now these are the random functions. So these are random functions which are used for generating which samples? Random samples. These are for testing, right? random samples. You are collecting what? Random samples, but in data science, you'll try to collect the samples, right? Suppose in data science, you take the values. Okay, you have a data set. You have a data set. Okay, you have a data set and you want to do some analysis. You want to do some analysis. Okay, then before analysis, you do what? Pre-processing of data. When you are doing pre-processing of data, you try to remove some outliers. Outliers are nothing but the values which are not within the range. Then how you find out that? You find out that by applying which one? Normal distribution. Normal distribution, right? Normal distribution, which is not within the range. Okay. So there are different techniques or different mathematical operations can be applied, right? But here you are generating a random samples, right? Yes. So these are various functions. There is, I think, one more function is there. So what is the name of that function is? Yesterday's, right? So random integer, yes, over, right? Yes. So these are various functions which are used for generating which values? Random values. Understood? So we have seen lot of ways of creating what array. So many approaches we have seen how to create an array means the array can be created by using various functions. The array can be created by using various functions. It is provided so many functions. It is provided so many functions to create what here? Array, right? Yes. So then next we'll talk about, so performing some vector operations on which one? Arrays, right? So before that, we'll just talk about what is a broadcasting. So what is a broadcasting? Broadcasting is there. So what is a broadcasting when you're working with the NumPy, right? So when you're talking about broadcasting, okay, it is similar to generally when you do some arithmetic operations, on two different data types, okay. For example, I'm saying 10 plus 1.5. If I'm writing a 10 plus 1.5, what is the result will be 11.5. Okay, 10 is an integer and 1.5 is what? Float. So these are two different types or not? Yes. These are two different types. But you are getting the result in which type? Broader type. You are getting a result in which type? Broader type. This is a broader type, 11.5. If I'm writing here 1 plus, okay, 1 plus 1.5 plus 1 plus 1.5 plus 1 plus 2j. 1 plus 1.5 plus 1 plus 2j. What is the result will be? What is the result will be? 3.5 plus 3.5 plus what is that? 2j. You are getting the result in what? Complex. In the same way, when you are doing arithmetic, yes, yes. When you're trying to do arithmetic on arrays, for example, there is 1D array, 1 comma 2 comma 3 comma 4 comma 5, and if I'm saying plus, I'm doing which operation? Vector operation means you try to apply on each element. What is the value I'm using here? 5. I'm using like this 1 comma 2 comma 3 comma 4 comma 5 plus what is that? 5. So 5 is an integer or not? Yes. So what is the result? I'll get 6 comma 7 comma, right? 8 comma 9 comma what is that? 10. So generally what is a broadcasting is? Broadcasting is a process of, okay, yes. Chandan Kumara. Yes. Where we use this random values of negatives and positives. Okay. Where we are using, is it this is real-time data, random data? This is real-time data, random data. So generally random samples are used for testing. Random samples are used for testing or not? Yes. Where it is used means this is. Okay, na? Right? This is not real-time data, right? It is a real-time data, random data. So real-time data, you generally work with the real-time data, but you don't work with what? Random data. So if you want to test it with some random data, then you generate it by using which samples? Random samples. Understood? If it is random, will you get output is the same always? No. You don't get the output as the same or not. You get the same output or different output? Different output. You want to test it by generating different samples. Getting or not? Yes. Yes. It's not real-time data. It is a random data. It is used only for, yes, testing, right? Yes. Now, where means again you have to talk about applications of data science. Again, you have to move to data science only, right? But it is not a data science. You are learning NumPy functions. Which function is used for what? Okay. But I try to tell you like examples, like where exactly it has been used, right? So what is a broadcasting is? Now this is important question, which is asked frequently, right? So what is a broadcasting in NumPy? This is a frequently asked question. You can say broadcasting here. What is broadcasting in NumPy here? So broadcasting is a NumPy. Broadcasting in NumPy is a mechanism that allows arithmetic operations to be performed. Just now I said arithmetic operations to be performed on arrays of different shapes by virtually expanding the smaller array's dimensions to match to what? Larger one. Broader means bigger. Narrower means small. Broader means bigger. Narrower means what? Small. Right? Yes. It enables element-wise operation between arrays without need to create explicit copies of which one? Data. Making your code more efficient and concise. Broadcasting only works if the arrays are compatible, meaning their shapes match in all dimensions or one of the dimension is equal, right? So I just take this one, right? Don't mind here. Yes. I don't want to write. So what is broadcasting means? Broadcasting in NumPy is a mechanism that allows when you are performing arithmetic operations to be performed on array of different shapes by virtually expanding the smaller arrays dimensions to what? Larger one. It enables element-wise operations between arrays without the need to create explicit copies of the data, making code more efficient. Broadcasting only works if the arrays are compatible and meaning their shapes match in all dimensions or one of the dimension is what? Equal to. One of the dimension is equal to. So there are some rules are there for broadcasting. When this broadcasting will happen? When this broadcasting will happen? When you perform? So when you perform which operations? Arithmetic operations. When you perform which operations? Arithmetic operations. When this broadcasting happen? When you perform arithmetic operations or vector operations. When you perform arithmetic operations or vector operations. Okay. So how broadcasting work? Now shape compatibility. First rule is what? Shape compatibility. For broadcasting to work, NumPy compares the arrays shapes element wise from right to left. So this is one rule. And padded dimensions. If one array has fewer dimensions and it is padded with ones on its leading left side to match the number of dimensions of the other array. And dimension matching here. If the dimensions are the same, they are compatible. If one dimension is 1, there is stretched to the match their size of the other dimension. If neither dimensions is 1 and they don't match, it will give which error? Value error. So these are the rules. Actually, these are what here? Rules. When it is doing which one? Broadcasting. These are the rules when it is doing which one? Broadcasting. We'll see with the example. So I'll explain with the example. Don't worry. So how broadcasting will work? So the first one is for broadcasting to work, NumPy creates. Sorry. First one is what is the first one is shape compatibility. What is the first one is shape compatibility. And what is the second one is padded dimensions. So second one is padded dimensions. And third one is dimension matching. Third one is dimension matching. I'll explain this with the example. Don't worry. What is exactly it is? Dimension matching. Yeah, see here. I'll explain with the example. Don't worry. Because I don't want to write. So I just taken from here. But all this we can use it. How broadcasting works. So you can perform arithmetic operations on array, right? So you can perform arithmetic operations on array. Vector operations, that you call it as which operations? Vector operation that is not supported by list. That is not supported by list. List, suppose you are working with the list. So there is a list 10, 20, 30, 40. Okay. There is another list 100, 200, 300, 400. What will happen if I say C equal to A plus B? What will happen if I say C equal to A plus B? A, B are what? List. A is what? List. B is what? List. When you say A plus B, what will happen? Concatenation. What will it do? Concatenation. Will it do addition? Will it add elements of the array? No, it doesn't add the elements of the array. What will it do? Concatenation. It will do the concatenation. If I'm writing print A comma B comma C. If I'm writing A comma B comma C, it is done what? Concatenation. But what I want to do? I want to what? Add. I want to add the elements of A with what? B. That operations you call it as what? Vector operation. These vector operations are supported by lister? No. But this vector operation supported by what? Arrays. This vector operation supported by what? Arrays. Now you can see here. Suppose I'm creating an array. So there is an array. Yes, NumPy array supported. So there is an array A equal to NP dot. Okay. So I'm creating NumPy as what? NP. A is an array. NP dot. I'm creating one array using which function? Array function. An array function is used to create an array using what? Iterables. Existing iterables. Now here I create an array with some 5 elements. How many values? 5 values. Now it is 1D array NP dot, I'm saying and again array. So there is an array. I'm creating one more array with the same number of elements. So is it shape of this both arrays are same or different? Same. Is the shape of this both arrays are same or different? Same. Okay. Now what I am doing is C equal to what? A plus B. C equal to what? A plus B. So what plus is doing? Adding. This is called vector operations. If I'm writing print A comma B comma C, okay, A comma B comma C, right? So when you run this, you can see 1 plus 10 is what here? 11. And 2 plus 20 is what here? 22. 3 plus 30 is what here? 33. Is it the size of this both and dimensions of this both are same or different? Same. If I'm writing some D equal to A plus, D equal to A plus 5. D equal to A plus 5. What is A? What is A here? Array. A is an array. A is which array? 1D array. And you are adding a value called which one? 5. 5 is which type? Integer. 5 is which type? Integer. Now, when you add an array with what? Integer. Is it written integer or is it written array? Array. Means this value is added to each element of what? Array. And it is written array with the same dimension or different dimension? Same dimension. Is it any broadcasting is done or not done? Not done. When the broadcasting is done is if the shape are not, if the shape is not same, right? Okay, see here, if the dimension or shape is not same, see here. So this dimension is the same or different? Same. This is having how many elements? 5 elements. This is having how many elements? 5 elements. Let us see one more. You can do all these operations here. I'm telling you A into B. A into B means what it is doing? Multiplying. This is called vector operations. 1 into 10 is 10. 2 into 20 is what? 40. So 3 into 30 is what? 90. And 4 into 40 is what? 160. Okay, 5 into 50 is what? 250. You can do all operations element wise. That is called vector operation. I'm writing A minus B, or I'm writing B minus what? A. B minus A. B minus A as said here. So B minus A is nothing but 10 minus 1 is what here? 9. Okay, 20 minus 2 is what? 18. Okay, 30 minus 3 is what? 27. Okay, and 40 minus 4 is what? 36. Okay, 50 minus 5 is a 45. So these are called vector operations are allowed on NumPy array. It is not allowed on what? List. On list, can you write like this? Can you write A into B? Can you multiply each element of A list with each element of B list? No. So immediately it gives what? Error. Cannot multiply what here? Sequences. Cannot multiply the sequences by non-integer of type which one? List. So immediately it is raised which error? Type error. So these vector operations are not supported by list, but this is supported by which one? NumPy array. You can write FG. So because here no broadcasting is done because dimensions are same or different? Same. When the broadcasting is done, see here, broadcasting in NumPy is a mechanism that allows arithmetic operations to be performed on arrays of different shapes. Okay, it will do it only if the arrays are with the different shapes. But is it these arrays are with the same shape or different shape? Same shape. So will it do any broadcasting? No, it will return. See, when you are adding two integers, when you add two integers, what is the result is integer. Is it any broadcasting is done? Tell me, is it any broadcasting is done? No, casting broader conversion is not done. You get the result in integer only. If you have a different shape, suppose assume that this is shape is, assume that how many values are there? Some two values, and this is having, assume that how many values? Three values are there. In this, how many values are there? two values. Here, how many values are there? Three values. Assume that this is having 1D and there is a 2D, right? 1, 2, 3, 4. 1, 2, 3, 4. So this is 1D array and this is what? 2D array. So is the shape of this both are same or different? Different. Then what will it do? What it will do? The result is broadcasted or not? Yes. It will create another array that contain the the result of this both. But the result is which array? Is it 1D array or 2D array? 2D array. And that is done based on certain rules and regulations. That is done based on some rules and regulations. It is not done directly. It is done by following some rules and regulations. Getting or not? Yes, it is a process of converting from one shape to another shape. But when it is do this, when it will do this conversion, no, when it is do this conversion, when you perform arithmetic operations, when you perform arithmetic operations, until unless you are not performing arithmetic operations, you don't find this, right? If you want to change the shape, you can directly change the shape, right? By using which attribute? Shape attribute. You can change the shape by using which function? Reshape. By using which one? Reshape, right? So G equal to B. So B, you can give A to the power of or B to the power of A. So I just write power of. Now you can apply all this. Whatever arithmetic operators are there, you can apply it. If I'm writing H equal to some B mod A. So what it returns? Reminders. What it returns? Reminders. Element wise. Vectorization is done element wise. Reminders. What are the reminders are? 0. So you want floor division. You want floor division. Okay. Now B slash is slash which one? A. And this is which division? Floor division. It is a floor division. Floor division means what you are dividing 10 with 1. 10 only, right? 20 with a 2. Yes, 10 only. 30 with a 3. 10 only. 40 with a 4. 10 only. 10.0, right? So you get 10. 40, 50 with a 5. What is the quotient is? 10, right? Yes. So all arithmetic, you can do it on matrices. But here, there is no broadcasting is happened. But let me explain. So how this broadcasting happens, right? We'll try to see with the different shapes. We'll try to see with the different shapes here. Not with a similar shape, but we'll have a different shape. Yeah, you understood? So vector operations are supported. Vector operations are supported. Okay, right? Yes. Now, what I'm doing is I'm creating an array. Yes. Now we will apply this broadcasting rules. Okay, na? So first one is, see here, what is the first one is shape compatibility. So for broadcasting to work, NumPy compares the array shape elements wise from right to what here? Left. Okay, it will compare from right to what here? Left. Right to left. So for broadcasting to work, NumPy compares the array shape element wise from right to left. Right to left. What it is comparing here? Shapes. From right to left. See here. For example, I'm creating an array. I'm creating an array by saying np dot. Np dot, what is that array? I'm creating 1D array. 1D array with how many elements? 2 elements. Okay, na? Then I'm creating np dot. Again, I'm saying array. Np dot array. Then I'm creating a 2D array. Here I'm writing some 3, 4. 3, 4, comma 5, 6. 5, 6. Okay. Now here I created 2 arrays. One is A and A dot n dimension and A dot what is that? Shape. So print B, comma B dot n dimension, comma B dot, what is that here? Shape. Is it shape of this both arrays are same or different? Different. What is the shape of this array? 2. One dimension having two values. It is having two dimension having? Yes. But what will happen? What will happen? If I am writing C equal to A plus B. I'm writing C equal to what? A plus B. I said C equal to A plus B. C equal to A plus B. And then I said print. What I printed here? C. Now when you see this, what is the result array is? What is the result array is? Is it 1D array or 2D array? 2D array. It means, is it broadcasted or not? Yes. It is broadcasted, but how it is broadcasted? By following some rules and regulations. By following some rules and what here? Regulations. So there are some rules which are used. Yes. So it enables element-wise operation between arrays without need to create explicitly copying what? Data, making code more. See, generally what? If this broadcasting is not there, what will happen? You have to change the shape. You have to copy the data from one array to what? Another array, and then you have to do it. That will take a lot of time, right? Yes. To avoid this, now NumPy provide a concept called which one? Broadcasting. Now suppose if I'm writing a D equal to B plus A. I said D equal to B plus A and I said print D. B plus A and print D. Now you can see 4, 6 and 6 and 8. But how it is doing this broadcasting? What are the rules which are used in broadcasting, right? So let me explain this with example again, right? Right? See here, the first rule is, so if the dimensions are the same, see here, if the dimensions are the same, they are what here? Compatible. But here, in the first example, is it dimensions are same or different? Same. Then they are compatible or not? Yes. Okay. Now you can see if one dimension, if one if one dimension is 1, it is stretched to match the size of the other dimension. If one dimension is 1, if one dimension is 1, it is stretched to match the size of what? Other dimension. If neither dimension is 1 and they don't match, a value error is what here? Rise. It means here, 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 dimension match or doesn't match? Match. See here, how many values are there? Two values. Two values. And here also how many values are there? Two values. Here how many values are there? Two values. Here how many values are there? Two values. Number of values. How many values are there? Two values. Otherwise, we'll take one more example. See here. For example, I create an array. Just see here. np dot array. So what it is comparing first? It is comparing. Just see here. What is comparing first? For broadcasting to work, NumPy compares the array shape element wise from from right to what here? Left. From right to left, it will compare it. From right to left, it will compare. So it is comparing the shape from right to left. So what is the right? Right to left means, now here, if we take, now this is a shape, right? This is what here? 2. 2 is what? Number of what? Elements. This is nothing but number of elements. Number of elements in each dimension. 2 is nothing but number of elements in each what? Dimension. And how many elements are there in each dimension here? 2 dimension. Right? 2 elements are there in each dimension. How many dimensions it is? one dimension. How many values are there? Two values. Two values. Is it a same or different? Tell me, is it a same or different? Same. Number of elements in each dimension is the same or different? Same. It is comparing from right to what? Left. Is it compatible or not compatible? Compatible. Then what will it do? Apply the operation and return. Return which array? Broader array. Broader array is which one? 2D array. Broader array is which one? 2D array. Are getting or not? Okay. Just to try to understand, I'll tell you some more examples. Otherwise, we'll see otherwise because time is not there. Now, in the next class, I'll tell you in detail on this, what is the broadcasting and how this broadcasting is done. Because this is very important when you're performing some arithmetic operations. Okay, I'll try to tell you with some more examples on this broadcasting, right? Not today, but we'll see tomorrow because it will take some time, right? Thank you. We'll see you on Monday, right? Yes. And tomorrow there is a workshop on prompt engineering. Now, if you want to attend, you can attend. Okay. It is a free online workshop I'm conducting at 10 o'clock. 10 o'clock. So if you are interested, you can attend, right? Thank you. Yes. Same only. So all these notes will be there in classroom. You can join the classroom, right? So here just introduction. You'll be learning introduction. Swana, Abhishek. Swana, not Telegram group. It is a Google Classroom. It's a Google Classroom. Okay. Swana. So this is documentation. Okay. This is a documentation. Yeah, I'll send it.